Welcome to the Manana Ventures YouTube channel. Please like and subscribe. Today we'll be doing trigonometry, the general solution. Okay, let's get right into it, wasting no time. Let's start with this third one here, which is cos theta plus 25 is equals to 0.231. Now, the first thing that I always like to do is determine which quadrants we are working with. Okay, so we use our CAST acronym. Okay, so cos that is positive, and it's positive in the first quadrant and on the fourth quadrant. Okay, now that we know that, let's go ahead and get our reference angle. Okay, so we will have theta plus 25, which is this whole thing there. Let me just put brackets, is equal to cos 0.21231. Okay, let's just simply gonna put that in a calculator. I'm gonna say second function. Oh, calculator is not working. Let's use another one. I'm simply just gonna say second function cos 0.231. Close the bracket and we get 76.64. So we get that theta plus 25, this thing is equals to 76.64. Now this is what we call our reference angle. Okay, now let's go to the first quadrant where we determine cos is positive. So on the first quad, I'm just gonna say first quad. Let me just complete the word quadrant. Okay, we have that this whole thing, theta plus 25, is equals to just the reference angle, which is 76.64. Now we always add a k, 360, because 360 is a revolution. A k can be any integer. Okay, so you'd probably say where k is an element of any integer. Right, now let's go to the third quadrant. I'm just gonna write it third quad. Okay, in the third quadrant we have that thing 25, okay, is equals to, now when you're on the third quadrant, it's 360 minus the reference angle, which is 76.64, plus k 360. Okay, now we can solve. I'd like to put all the numbers together, so I'll take that 360 minus 76.64, then I'll bring in this 25 minus 25, and then plus k 360. Okay, now put all of that in the calculator. I'm gonna have 360 minus 76.64 minus 25. We get 258. Get that. 258.36 plus k 360. Okay, so that's our final answer, where k is an element of an integer. Right, we're done answering that question. Let's move on to the next one. Now it's sine. The next one is sine 2 theta is equals to minus 0.327. Okay, likewise, I like to start with determining which quadrant we are working with here. So I'll just put the cast over here. Okay, so sine is negative on this quadrant and that quadrant, the third and the fourth, because it's positive on those two. Okay, that's fine. Let's go ahead then and find our reference angles. Okay, so we're gonna say 2 theta is actually equal to sine, and then we do not put that sign, we put the actual number. We do not put the negative sign. Okay, the negative sign just helps us to figure out which quadrant we are working with. Okay, now we're gonna say shift sine 0.327. Close that. And I get 19, let's say 19.1. So 2 theta is equals to 19.1. And I'll call this our reference angle. Okay, now let's go ahead and solve it. So on our third, it's our third quadrant. Third quadrant is 180 plus theta. So we'll have 2 theta is equals to 180 plus our reference angle, which is 19.1 plus k 360. Okay, and then what I'd like to do now, before I put everything in a calculator, is that I'm gonna put these together. Let's just do it. 180 plus 19. So let's say 19 plus 180. 199.1. So we get 199.1. So that's still 2 theta. Plus k 360. Okay. And then from there, I need to divide everything by 2 in order to get my theta. Okay, so 199 divided by 2, and then I'm going to get 99.58. 99.54 rather. Plus, okay, I need also to divide that 360 divided by 2, 180. We get 180. So now it's k 180 instead of 360, because everything is divided by 2 in order to get theta. Okay, now we need to move to our fourth quadrant. Okay, so let's do this. Let's just put a line through. Our fourth quadrant, our fourth quad. Okay, now we have 2 theta is equals to, fourth quad is always 360 minus reference. 360 minus the reference, which is 19.1 plus k 360. Okay, likewise, just like we did on the other side, let's put these numbers together. It's 360 minus 19.1, and we get 340.9 plus K 360. Now, to get theta on its own, need to divide everything by 2. So this divided by 2, you get 170.45 plus K 360 divided by 2 is 180. We did it that side. Okay, so now that would be your general solution. But now, if you notice in the question, they gave us that they want the answers to be actually between minus 180 and 180. So what we're going to do now is that we're just going to simply say, okay, let's start here. 99.5 it's within the parameters. So 99.54 is an answer. Okay. And then what we're going to do, if we add this, well, it's already, if we put a 1 here, the integers are 1, minus 1. Those are the ones that we normally use, minus 1 and 2, minus 2. So if we put minus 1 there, we're going to have 99.54. A minus 1 changes this sign into a negative, so we'll have a negative 180. And then we get 80.46. Now that's within 180 and negative 180. So negative 80.46. Okay. Well, the 2 will be outside. Okay, this side, 170 is also within the parameters. So we will have it as an answer, 170.45. Let's see what happens when we substitute a negative 1 for a K. So we're going to have 170.45 minus 180. And we'll get 9 minus 9.55. Okay, so these would be your answers. You'd have 4 answers for this question when given that we need theta to be within 180, negative and positive 180. Okay, I think let's move on to the next one very quickly. The next one is, we will have, I think it was 3, if I remember correctly. It was 3 10 squared theta plus 2 10 theta is equals to 0. Okay, now there's too many of them. We need one in order to work the general solution. So what we're going to do is that we're going to simply factorize. Okay, so the common factor between these two is 10. So we'll take out 10. Okay, so from this term over here, let's turn theta. From this term, we'll take the 3 out and then 10 theta. That plus stays. And then from this one, it's just a 2. And all of that is equals to 0. Such that we will have 2 solutions that 10 theta is equals to 0 from there. And we're also going to have that 10 theta is equals to minus 2 over 3 from there, that expression. Okay, so working with this one, well, okay, we can do this. Let's do this. Theta is equals to 10 0. Okay, and that will give us a 0. 10 of 0, 10, negative 1 of 0 is 0. Okay, so that means this is our reference. 0 is just 0. Now, the answer for this one is that theta is equals to 0 plus k. Now, for 10 doesn't repeat itself every 360, but it repeats itself every 180. You just have to check the graph to verify that. Okay, so we're done with this side. This side, we need to determine first of all which quadrants we are working with. So you write your cast. Now, 10 is negative in that quadrant, in that one, second and the fourth. Okay, and then from there, let's solve our reference angle. So we will say theta is equals to 10, negative 1 on top, and then we'll put 2 over 3. Remember, this negative number, we do not put it here, but it just tells us which quadrants we are working with. Okay, so in solving our theta, we are going to get 10 2 divided by 3. And we get 33.69. Now this is our reference angle. Right, now we need to solve the actual, let's put a line there, the actual theta. So we said we are working with the second quadrant. So on our second quad, we will have that theta is actually equals to 180 minus the reference, 69, plus 10 repeats itself every 180 times, 180 degrees rather. All these numbers are in degrees, by the way. So we'll put that in a calculator. We will have 180 minus 33.69. Get 146. Okay, so we will have that our theta is actually equals to 146.31 plus k 180. Okay, and then that's on the second quadrant. Now on the fourth quadrant, fourth quad, it's an A, we will have that our theta is equals to 360 minus our reference angle, which is 33.69, plus k 180. Put that in a calculator. It's 360 minus 33.69. We get 326. Theta is equals to 326.31 plus k 180. That, ladies and gentlemen, concludes. Just remember to include that where k is an element of an integer in all of your answers. Okay, thank you very much.